Hi students, the subject we are going to start today is Physics for Electronics Engineering, the semester 2 subject for the ECE students. I'm going to cover all the units from today. The first unit of the paper is Electrical Properties of Materials. So, what is the electrical property of a material? It is defined as the ability of the material to conduct electrical current. So those properties include resistivity, conductivity, temperature coefficient of resistance, dielectric strength, thermoelectricity. So what is resistivity? It is the property of the material which resists the flow of electric current through the material. That is, we consider there are multiple electrons flowing in a wire. We need only few electrons at the output side. That is a few current. So I am connecting a resistor which resists most of the flow of electrons, that is most of the flow of current, and gives out only required amount of current that I need for the device at the output side. For this I am using the resistor. Now coming to conductivity. Conductivity, it is the property of the material which allow flow of electric current through them. The valency electron is responsible for the free flow of current, that is for conduction. So what is a valency electron? In an atom, the outermost shell has one electron which is slightly bounded to the nucleus of the atom. This valency electron, on getting certain amount of energy, it gets excited and jumps out of the bond and forms a free electron. This free electron starts to bounce to one atom to another to form the conductive path. This free electron from all atoms jumps and flows through the direction of electric field. Now, conductivity and resistivity, we could say they are related to each other. If the resistivity is going to increase, then the conductivity almost decreases. If the resistivity decreases, the conductivity increases. So if you think there is no resistance, then sure there will be a free conduction path. Temperature coefficient of resistance. Temperature coefficient of resistance of material indicates change in resistance of material with respect to the change in temperature. So coming again to the concept of the resistivity. If we are going to resist the certain amount of electron flow, so what happens at its terminal, the electrons will start to get accumulated. Because of this accumulation, what happens? The electrons will vibrate. Because of those friction effect, what happens? The temperature will get automatically increased. Because of this increased temperature, what happens? The conductivity starts to decrease. So whenever the resistivity and the temperature increases, conductivity gradually decreases. Resistivity and temperature are related equally. The next is dielectric strength. It is defined as the electrical strength of an insulating material. In a sufficiently strong electric field, the insulating properties of an insulator breaks down, allowing flow of charge. Okay. So, what does the dielectric mean? The dielectric is nothing but the insulator. What is an insulator? Insulator stops the electron flow from one material to another. It never allows the electron to flow from one to another. That is, it does not pass electricity. It does not allow the material to pass electricity to another material. This is what the insulator does. So, I need my electron to flow out of this insulator. So in order to get my electron out of this, I need this insulator to get breakdown. So in order to get breakdown, this insulator has to be given some certain voltage, certain strength of electric field. So that strength is known as the dielectric strength. How much this insulator could sustain to break. That is what meant by the dielectric strength. Dielectric strength is measured as the maximum voltage required to produce a dielectric breakdown through a material. If this gets breakdown, then my electrons will get transferred from one material to the other. So here the best example is a vacuum. It has the highest dielectric strength. Because a perfect vacuum contains no material to break down and is therefore the perfect electrical insulator. Thermoelectricity. This effect is nothing but a direct conversion of temperature differences into electric voltage. Because of the varying temperature, what happens? The charge carriers in the material start to diffuse from the hot side to the cold side. So, because of this, there will be a transfer of electrons which causes generation of electricity. So, it is used in many power stations to generate electricity, and also this is used in temperature controllers. So, these are the properties, electrical properties of the materials.